Good morning and once again welcome to my YouTube channel, Pearson at Excel International Math. My name is Tom, and today we continue Apex Mathematics 1 and we are on page 165 and we are going to tackle a very important part of the topic, which is called second order derivative. Second order derivative is basically a derivative of a derivative. We are told that on that page you can find the rate of change of the gradient function by differentiating the function twice. You can find the rate of change of gradient function by differentiating a function twice. For example, if you have y is equals to 5x cubed, dy dx is supposed to be 15x squared, and then the second derivative is d squared y over dx squared. This is how we write the second derivative. Is now we differentiate this gradient function to give us 30x. That is simply the second order derivative. This is the gradient function. This is the gradient. This is the gradient. This is the gradient function. This is the gradient function. And this is the rate of change. This is the rate of change of this is the rate of change of the gradient function. The rate of change of the gradient function. We may write it, or rather we are being told differentiating a function y is equals to fx twice. If you differentiate this twice, you get the second order derivative, which will give you either d squared y over dx squared, or when you are writing it in terms of fx, f double prime x. F double prime x means differentiating twice. But basically it's simply a gradient of a gradient, a derivative of a derivative. So with this, we need to look at example 12. Example 12, given that y is equals to 3x 5 raised to power 5 plus 4 over x squared, find 1 a d dy dx, and that we are going to do it straight away. But of course, before we do it, we cannot differentiate with respect to a variable that is at the denominator position. So the very first step is to write y is equals 3x5 plus 4x raised to power minus 2. And therefore, dy dx becomes 15x4 minus 8x minus 3. And that is just like it. You may want to rewrite this one, return it to where it was originally, and you'll have 15x4 minus 8 over x raised to power 3. Either way, you are home. But the second part, which is part 2 or part B of the equation, what is d squared y dx squared, or rather the second derivative? The second derivative, what we need to do is we need to differentiate the first derivative. We need to differentiate the first derivative. And we're going to have 60x3 plus 24x minus 4. That is just like it. If you want to write it in originally in its original format, then you're going to have 60x cubed plus 24 over x raised to power 4. And that is just like it. And that is as far as example 12 is concerned. I don't know whether we can explain example 13 in the same video, because given that fx example, because it's one of the same thing, is equals 3 root x plus 1 over 2 root x. Find first of all the first derivative and the second derivative. That is the question. If this is fx, first of all, let us write fx in a differentiable format. This is 3x power a half plus a half x power minus a half. Having said that, now the first derivative is going to be a half times 3, which is 3 over 2 x raised to power minus a half, minus a half times minus a half is minus a quarter x raised to power minus 3 over 2, because it simply reduces by 1. So you may leave it that way, or rather you may want to write it in form of 3 over 2 the root of x minus 1 over 4 x raised to power 3 over 2. Either way, this is just comfortable with everybody. Now, the second derivative is, now we differentiate this one to get f prime double prime x is going to be 3 over 2 times negative a half is going to be negative 3 over 4 x minus 3 over 2. Of course, negative and negative gives us a plus 3 over 2 times a quarter, which is 3 over 8 x raised to power. Reduce this by 1, you get minus 2 and a half, which is minus 5 over 2. So if you want to rewrite it in such a format that we have x's at the denominator, you're going to have minus 3 over 4 x3 over 2 plus 3 over 8x5 over 2. Either way, this is also okay, because we get it at the final level, and this is what we have to show. So every time you're talking about second order derivative, please note what we should be doing. We should be differentiating the derivative itself. All right, and before we get over with this video, very importantly, and NB, I want to mention something to do with NB here. At the turning point of a curve, it could be maxima or minima. Please note dy dx is 0. Remember this. At the turning point, dy dx is 0, though we have had this before, but it is important to remind you, because in the assignment there are some questions that will require this information.